Right now, the supermassive black hole at the center of galaxy M87 is still bending light around its shadow, twisting photons that should never escape back toward us, and the scientists at the Event Horizon Telescope have no way to stop it. They captured that light. They photographed the impossible, and what they found hiding inside that image is the part they are afraid to say out loud. That object is called M87 star, a black hole. 6.5 billion times the mass of our sun, sitting 55 million light-years away. For most of human history, black holes were theoretical, math on a chalkboard. Einstein predicted them but never expected anyone to actually see one. Then in April 2019, 8 telescopes spread across the planet locked onto the same point in the sky at the exact same moment. Together, they built a telescope the size of Earth itself. And they captured light from the edge of something that should be invisible. That blurry orange ring you have seen on every screen, in every headline, that is the shadow of a black hole, and it should not exist. But here is what nobody is telling you about what that shadow actually contains. A black hole does not emit light. It devours it. Anything that crosses the event horizon, the point of no return, disappears forever. The physics is absolute. Light cannot escape. So how did they photograph its shadow? The answer lives at something called the photon sphere. At exactly 1.5 times the radius of the event horizon, photons, particles of light, do not fall in and do not escape. They orbit. They circle the black hole like water circling a drain, and some of them, under exactly the right conditions, get flung outward, back toward us. After traveling 55 million years, those photons landed on detectors in Chile, in Hawaii, in Antarctica, and in Spain, all at the same moment. What we photographed was not the black hole itself. It was the ghost of light that almost didn't make it out. But here is where the scientists ran into a wall. The shadow should have a precise, predictable size. General relativity, Einstein's framework that governs all of gravity, gives you an exact formula. The shadow should be 2.5 times the Schwarzschild radius. That is what the math demands. When the team finished processing the data and ran it against the models, the shadow came out slightly larger than predicted. Not by much, but enough to matter. Enough to make people go quiet in rooms. The Event Horizon Telescope collaboration published the measurement, compared it to every simulation they had. The models did not match. Astronomers told the press it fell within acceptable uncertainty. But that is not the same as saying it was right. Something about M87 star does not line up, and they have no clean explanation. But that is not even the part that worries them. Here is the strange part: it should not be possible at all. Those photons in the image did not take a straight path to reach us. Scientists can calculate exactly how many times each ring of light orbited the black hole before escaping. The bright outer ring, light that circled once. A thinner ring inside it, light that went around twice. A fainter ring beyond that, 3 full orbits. Then 4. Then 5. Each one dimmer. Each one a separate record of a slightly different path through warped spacetime. The rings nest inside each other like echoes stacked on echoes. And here is what that means. The image of a black hole is not a single photograph. It is dozens of photographs layered on top of each other, taken from every angle simultaneously, compressed into one glowing circle. And buried in the innermost ring, the photons that circled closest without falling, scientists found a faint asymmetry. A brightness on one side that no current model of extreme gravity can explain. The Event Horizon Telescope team published hypotheses. They did not publish answers. And when the James Webb Space Telescope turned toward M87, it did not clear things up. It made them stranger. This matters because there is a black hole at the center of our own galaxy. Sagittarius A star, 4 million solar masses, 26,000 light-years away. We photographed its shadow in 2022, and it showed the same unexplained asymmetry. The same patterns that refuse to fit the models. Whatever is incomplete about our understanding of gravity at the edge of a black hole, it is not specific to M87. It is universal. Every calculation that explains how stars form, how galaxies evolve, how dark energy shapes the universe, all of it runs through the same equations. If those equations break down at the boundary of the event horizon, our map of the cosmos has a gap in it, and we have been building everything on top of that map. The photons in that image left M87 55 million years ago, long before humans walked the Earth. They orbited a black hole, circled it over and somehow broke free. They crossed the universe, and they landed on a detector we built. We caught them. We photographed a shadow that should be invisible, and the image is still telling us something we do not yet know how to read. So here is the question nobody can answer. If the shadow of a black hole is already breaking our best equations, what happens when we finally look close enough to see what lives inside the ring?